In a perfect world, every problem that required using the central limit theorem would begin, use the central limit theorem to find. We don't live in that world. In a nearly perfect world, every problem that required using the central limit theorem would begin, suppose a random experiment is repeated n times. Find the. We don't live in that world either. In a somewhat perfect world, and never mind, you get the idea. The important result about the central limit theorem is that the distribution of the sum is approximated by the normal distribution. But for any sum of independent and identically distributed random variables, we have the expected value of the sum is the sum of the expected values, and the variance of the sum is the sum of the variances. For example, suppose a charity receives 100 contributions, and they're distributed with a mean of 200 and standard deviation of 50, and probability distribution of, well, who cares? What's the probability the charity received more than $21,000? So let X be the sum of 100 trials for a random experiment with mean and standard deviation. Since we're summing 100 contributions, our mean and variance will be 100 times the mean and variance of any single outcome. And so our mean will be now we're given the standard deviation, so the variance is the square, and so the variance of the 100 contributions will be, and so the standard deviation of the sum will be, and so we know the mean and standard deviation of the sum. Now we want to find the probability that the sum is greater than 21,000, and we know the mean and standard deviation, and since we're repeating a large number of trials, we know that the sum can be approximated by the normal distribution. And so we can find our z-score. And we find. And so that tells us our probability. Now, a useful way to study is ask a different question. So let's use the same setup, but let's ask what the 80th percentile of the total contributions. So again, if we let X be the sum of the 100 contributions, then X will be a random variable where we have a given mean and standard deviations. The 80th percentile corresponds to the z-value where the probability is 0.8. From our table, we find that this occurs at, and we'll convert that z-value back into an x value, which will be, and so 80% of the time, the total contributions will be 20,420 or less.